It's a radical house. Yeah, that's right. You know those little house things? We're going to talk more about those. Welcome to Chapter 6. Let's jump into our radical signs. Okay, let's get some vocabulary words out of the way. So if we've got a radical sign, so if we've got a number right here, that's what we're going to call our index. Our little house thing, I've called it house, but it is technically the radical sign. So those are the words we're going to use, and then the number underneath, the A, is a radicand. Now, I'll admit you probably won't hear me use that one that much, but the index and the radical sign are both good words to know. So if we're looking at roots, it's good to know some patterns. So if we have an even root and our radicand is positive, there are things that we know. We know that the type of roots that we're going to get are real, or like kind of normal numbers, and we're going to get plus or minus. So then if we have an odd index and a positive radicand, we're going to get a real number. We're only going to get one positive number. So that's what we're kind of doing here. So then if we have an odd index, remember that's a number outside of the house, and the number inside the house is negative, we know that we're going to get a type of root. It's going to be real, but in this case, because it's odd, it's going to be negative. So the answer would be negative. And then we've done this before. If we get an even index and a negative sign under the radical sign, we're going to have two imaginary numbers. So we'll just have an I attached to it, which we are perfectly capable of handling at this point. So let's try. Oh, one more thing. And if there is no number, right here, then it's a normal square root. It's an implied 2. So if there's no number right there, then we assume that it's 2. So with that, let's try some examples. Jump into these examples. It's probably good to know how to use your calculator. For doing square roots, normally we've been using the second x squared button, and then we can put in something like 16, push enter, and we get our answer is 4. But for cube roots, third roots, or fourth roots, you can always go to math, and this number 5, I gotta go back real quick, will allow you to dictate what root you're doing. So if I want to do a fourth root, I would type in 4, and at least on this calculator, I would then go to math, and I would push this number 5, and notice how that 4 automatically goes up to the, as in the index spot. So then I can do, something absurdly crazy. This is one of our examples, and it's going to automatically give us our 7. So your TI should work exactly like this. If you've got a Casio, Google it, figure out how to do it, because it's going to be a super helpful tool. So I grabbed my calculator for this, so I would recommend doing the same. So if I'm going through, I'm not going to do all of these, but notice how they put some of these negative signs in weird spots, so you need to make sure that you kind of understand what's going on. So if I were to do the square root of 16, that's going to be our 4. So the square root of 121. So here that negative sign is on the outside of the radical sign. So we're just going to put that negative sign in our answer, but it does not affect the radical part. So I'm going to do the square root of 121, I think it's 11. And so then that negative sign is just going to stay on the outside. And then the square root of 289, I'm just calculating it out. So this one right here, let's see what the calculator does. So I'm going to do square root of 4 divided by 25. And I got 0.4. Let's see, and it'll turn that into a fraction. I want fractions, but if your calculator didn't do all that for you, you could also do the square root of 4 and the square root of 5, and then keep it as a fraction. So that negative sign comes over, then we've got 2 over 5, and that's our square roots. So our cube roots is going to be the exact same. I'm going to use my math button. I told you in the last clip that you can use the 5 function or whatever that is. 4 is also automatically a cube root, so I'm going to use that, put 8 in, we're going to get 2. Now I'm going to skip that one, so I'm right here. because it's got a negative sign on the inside. So normally we might panic. We might go, oh no, it's an imaginary number. But in this case, it's not, because it's an odd root. So I'm going to do my cubed root, and I could probably even type it as is into my calculator, and then it is going to tell me that it is -5. So just be aware of these roots, these negative signs. So same thing here. We got a negative sign on the inside. It's fine. It's a cubed root. Cubed root of 27 is 3. So my answer is going to be 1/3. So same thing down here with our fourth roots. The whatever root to 1 is always still going to be 1. So our answer there is going to be -1. If you don't believe me, use your calculator. That's fine. I did the fourth root of 2,401 in that last clip, and that was 7. And then let's do, we've got a negative fourth root of 4,096, and that is going to be 8. And again, I'm just using my calculator for this. So I don't expect you to memorize some of these higher order roots. Okay, we're looking at number 5. We've got a negative sign underneath the square root, but this is a cube, so that negative sign is just going to stay as a negative, so not a big deal. And we need to find a perfect cube that comes out of 250. I don't know what that is unless I cheat and look at the solution manual. So the way I would figure that out is do my little multiple game. So I'm just going to start with 10 because I know that 250 is divisible by 10. So now we have 10 times 25. I know 10 is 2 times 5. And then 25 is 5 times 5. So we need 3 numbers that match. And in this case, we have 3 numbers. Those are all 5s. I know my handwriting is terrible, but they're 5s. So then that 5 comes out and that 2 stays inside of the radical. So then the 5 is going to come out. So we're going to have 5 cubed root of, we'll have pull that negative sign out. And we got 2 left over. So our final answer is -5 times the cubed root of 2. Looking at number 7, hopefully you noticed that we are dealing with a fourth root, and so hopefully you've picked up on the pattern that since we're dealing with a fourth root, and yes, I'm going to do a factor tree, you need 4 of the same numbers in order to pull something out of the radical sign in order to simplify it. So here we go. I'm looking at 162. 2 is, of course, my favorite number in the world. 162. Oh my gosh, I can't type it in. 162 divided by 2 is 81. Ooh, I know what 81 is. 9 times 9. And the 9s are all both 3 times 3 times 3 times 3. So we are looking for 4 of the same numbers, and those numbers are going to be 3s. And so that 3 is going to come out of the radical, and that 2 is going to stay behind. So the 3 comes out, so we've got this 3, and then we've got this 3, and then it's the fourth root, and what do we have left over? 2. So then our final answer is then going to be 9 fourth root of 2. So there you go. Again, whatever number this is the number of numbers that need to be repeated in order for them to be simplified out of a radical sign. So looking at 11, it's a cubed root. So my 216, I'm gonna plug that into my calculator, see what it looks like. Math, number 4, 216. So 216 is one of my perfect cubes, so that's convenient. So it's 6 according to my calculator, so that's just going to come out. And then we've got m cubed underneath a cubed root. So those are going to cancel out, and we're just going to have m left over. And we have 2 n's, n cubed times n cubed, and those are going to cancel out, and we're going to have n squared left over. So hopefully you're noticing a pattern that you can kind of sort of take this number divided by this number, and that's going to give you that number. Okay, here's where it gets a little bit more interesting. So 1 and 2, we're going to start with our square roots. We just need to simplify. If we put square root of 117 in our calculator, we're going to get a decimal point. So normally what we could do, we could rewrite 117 into 9 times 13, and it'd be the square root of that and square root of that. And then we would get 3 square root of 13. If you didn't know that off the top of your head, which I sure as heck didn't, you would have to do that factor tree that I showed you. So if you take 117, 117 is divisible by 3. And if you don't know that trick, if you add up each one of these digits, if that number is divisible by 3, the whole thing is. So 7 plus 1 plus 1, 7, 8, 9. So we've got 117 divided by 3 times 39. 39 is still divisible by 3. And then we've got 3 times 13. And then I've been telling you, hey, find a pair, and that pair comes out, and then the single numbers stay in. That's all still true with squares or square roots, but with our 3's down here, you're going to need to find 3 numbers that match up as opposed to the 2. So we are going to do number 2 real quick. If we were to factor it out, we would have 4 times square root of 64 times square root of 5. And so our final answer after we do the square root of 64, which is 8, would be 32 square root of 5. Okay, number 3 is the more interesting one. So here we go. We've got the 2 out front. That 2 is going to stay there. We're going to multiply with whatever comes out of the cubed root. So this time we've got 48. So I'm going to do my factor tree of 48. 48 is divisible by 2. 2 times 24. 24 is still divisible by 2. 2 times 12. 12 is divisible by 2. 2 times 6. And 6 is also divisible by 2, but I know that that's not going to be super helpful later on. So now we're dealing with cubed roots. Since we're dealing with cubed roots, we need to have 3 numbers that match up. So we've got 1, 2, 3. So that's the number that's going to come out, and then the rest of them stay inside of the radical whenever we're simplifying. So then only that 2, just a 2 comes out because it's a cubed root. So we took the cubed root of all 3 of these numbers, which would be like 8. Yeah. And then that comes out. So now we're going to have this 2 times this 2 times the cubed root of whatever we have left over, which is 2 times 3. So we're going to write 6. So our final answer is going to be 4 times the cubed root of 6. So again, it's the same process, but we're adding one more step, one more thing to look for, that the numbers that you have to match up is going to be dictated by that number right there. And remember, if there is no number right there, it's an implied 2. Okay, but those exponents aren't always going to be even or a direct multiple. So if we're looking at 13, we've got the cubed root of 64. There's a negative sign, but that's okay because it's a cubed root, not a squared root. So negative 4 is going to come out. So if you just use your calculator, cubed root of negative 64 is negative 4. Okay, so now let's deal with these variables. So if I look at my x to the power of 10, I can divide that into x to the 9th times x. So you know the power rules, that these would just get added together, so that's the same as saying x to the 10th. Well, if I rewrite it like that, it's a little bit easier to see that when we take the cubed root of this one, we are going to have x cubed left over, and then this x is going to stay in the square root, or in the cubed root, so we're going to write that over here. That's not right. There we go. Okay, so then we've got y to the 21st. 21 is a direct multiple of 3. So then if I were to take 21 divided by 3, we're going to have y to the 7th. So, and because I'm working on an iPad, I can do fun things like that. So my final answer is this guy right here. So you can always break up those multiples. We can do that because they're multiplying together. Be careful if you have addition, subtraction, and multiplication. You can't just switch and flop that with those two things. So you have to be careful with that. Hey, this is an algebra class. So what happens if I have a variable or a letter? Well, let's talk about variables. So number one, if you've got a variable that is an exponent underneath a radical sign, it needs to be a multiple of that radical sign. So what do I mean by that? So if you have a square root, the exponents must be multiples of 2. Those are the things that can come out of the square root to be simplified. Cubed roots must be multiples of 3. 3, 6, 9. Yeah, 3, 6, 9, things like that. Fourth roots, exponents must be multiples of 4. Hopefully you're seeing the pattern. So then what does that look like? So if we're looking at number 9, so you're going to do the number just the same as we've been doing. So 32, I'm going to do my little factor tree, 15, 16, 8 times 2, 2 times 4, 2 times 2. So let's see here. Got 1 that can come out and then 2 that can come out. So 2 number 2s are coming out because it's a normal square root. So we're going to have a 4 on the outside of my radical. Okay, let's look at the variables now. So we've got x to the 4th. When we take the square root, anytime we, let's say, take the square root of x squared, that is just going to equal x. Okay, so they cancel each other out. They're opposites of each other. And so what we need to do is we need to divide this up into like groups of x squareds. How many groups of x squareds do we have in that case? We have 2. We have x squared times x squared. So if we cancel both of those out, so you know we have square root of x squared times square root of x squared. That's going to equal x times x. So we're going to have x squared on the outside of the radical. So we're going to move this down a little bit, make some space. So now this y, it's a little weird, it's odd. So we already know that one of those y's is going to stick inside of the radical. So we're going to put that one there. And then the number of y's we have left over, that would be 8. So how many groups of 2 can we get in 8? We can get 4. So hopefully you're seeing kind of the multiplication division thing happening here. So we would have y to the 4th. So in our next section, we're going to look more deeply into this process right here and hopefully try to simplify it up a little bit. But for now, we want to get the concept first. And I almost forgot this 2 is just kind of hanging out here. So that 2 would be right there inside of the radical. All right, last but not least, we are looking at 15 and it's all variables. So that's kind of fun. I almost dropped my coffee. So we got the 4th root of w to the 4. So those just cancel out. We're going to have a w on the outside of our radical. Now 17 is a weird number. I don't know anything about 17. And I'm bad with multiples. So I'm using my calculator and I'm just walking you through my thought process. So I'm like, gee, I wonder what number I should use. So I take 17 divided by 4. I get 4.25. Okay, so if I were to round that down, if I take 4 times 4, that's going to be my closest multiple. That's 16. So I can divide that v into v to the 16th times v. And then I can take the 4th root of that 16, and then that other v is just going to stay underneath the radical. So 16 divided by 4 is 4. I knew that. So we're going to have v to the power of 4, and then we're going to have the 4th root of v left over. So this is going to be our final answer. So I will see you in class. We're going to try some more examples, and let's get to it.